In estimating the definite integral of cosine 4x dx from -1 to 4 using the midpoint rule with n equals 10, we can estimate the error in the approximation using the error-bound formula shown below, where the error is less than or equal to the cube of b minus a divided by 24n squared times the maximum of the absolute value of the second derivative of the integrand function over the closed interval from a to b. So in the formula, a and b are the limits of integration, n is the number of rectangles or number of subintervals, and then to find the maximum of the absolute value of the second derivative, we can use calculus techniques or simply analyze the graph over the closed interval from a to b. Let's begin by determining the second derivative. F of x is the integrand function cosine 4x. Notice how we have a composite function where the inner function u is equal to 4x. First derivative is equal to the derivative of cosine u with respect to x, which is negative sine u times u prime, or in our case, negative sine 4x times 4, giving us negative 4 sine 4x. And now we can find the second derivative, which is equal to negative 4 times the derivative of sine 4x, which gives us negative 4 times cosine 4x times 4, or negative 16 cosine 4x. Now remember, we have to find the maximum of the absolute value of this function over the closed interval from a to b. I've graphed the second derivative below, and we can see the maximum function value is the y value or function value of 16. And therefore we'll use 16 as the maximum of the absolute value of the second derivative, which means the error when evaluating the given definite integral using the midpoint rule with n equal 10 is less than or equal to the cube of b minus a is the cube of 4 minus negative 1 divided by 24n squared, which gives us 24 times the square of 10, and then times 16, which again is the maximum of the absolute value of the second derivative over the closed interval from a to b. And now we'll go and evaluate this. In the numerator, 4 minus negative 1 simplifies to 4 plus 1 or 5, giving us 5 cubed in the numerator, which is 125. In the denominator, we have 24 times 10 squared. 10 squared is 100. 24 times 100 is 2,400. And then times 16. As a decimal, we have 0.83 repeating. To get the exact values of fraction, click the Convert to Fraction button on the far right, which gives us 5/6. So the error is less than or equal to 5/6, which is a decimal to 4 decimal places, would be approximately 0.8333. I hope you found this helpful.